Hello, everyone. Hello. Hi. Hi, everyone. I am Liz Albert. I work at Galvanize, actually at our corporate headquarters in Denver, but I am here to welcome you to the Galvanize Soma campus. How many people have been here before? Yes, thank you. So you are familiar with it. We have 5 beautiful stories in this campus. If you haven't been here, please feel free to come by. We'll walk you through a tour. But for tonight, I wanted to thank H2O and IBM for bringing this wonderful Kaggle Grandmaster panel to our learning community for technology. And yes, so thank you so much. And I'm going to hand it over to Rosalie and let her kick this off.
All right. Before I kick it off, I actually wanted to go ahead and say thank you to Liz and Galvanize for all their help to make this a huge success. So thank you. So hi, everyone. I'm Rosalie, and I'm the Director of Content and Community at H2O.ai. And before we started tonight, I was actually curious, how many folks in the audience do Kaggle? If you raise your hands, a lot of Kagglers. Do we have any other Grandmasters in the audience? If yes, I was going to have you join the panel, so you might not be okay. Awesome. So before we get started here, I thought the great way to kick it off would actually to be asking our Grandmasters to introduce themselves. So Branden, if you want to take it away.
Hey everyone, I'm Branden.
Oh, are you on? Hello? No? I'll give you my one.
Right. Sounds good. Hey, I'm Branden. I'm a customer data scientist at H2O. And a lot of my work is revolved around working with accounting stuff, auditing, trying to help auditors find unusual accounting activity, stuff like that. In my past, I used to work for a home warranty company where I did a lot of general analytics, trying to figure out if customers would cancel, prices for options, and people would file claims and stuff like that. So a lot of stuff, insurance and accounting is kind of my background, I guess.
Hello everyone, my name is Vladimir, and what I want to say. So about 3 years ago, I learned that Kaggle exists. So I was taking some online class, and in one of them it was mentioned that there is a Kaggle, some platform in which you can check your expectations about your skill set in machine learning and reality. And first few attempts were epic fails, but then I got used to it. And at the time, 3 years ago, I was doing my PhD in physics in UC Davis, and again, I want to emphasize that physics is really great background for deep learning. Many people don't agree with me, but because in my personal subjective opinion, physics is much better than computer science in this sense. Okay, what's happened? How Kaggle helped me and influence? So I was finishing my physics degree, I was getting my PhD, and then question was next, so what? Because I looked at the postdocs, I didn't like salaries, I didn't like how academia was a swamp, and there was Silicon Valley around the corner, and it looked very exciting, and I watched this TV show Silicon Valley, and I got even more intrigued, and things like this. And question was how to find a job, how to find first data science job. I was taking online classes, reading books, reading papers, it was very great and cute, but no one really wanted to look at my resume. And in parallel, while looking for a job, for the 6 months, from, learning about Kaggle and then getting in a job offer, and at the time I was in top 200, I was doing Kaggle, and it helped me a lot. So Kaggle was one of the factors that helped me to find my first job. My first job was not that excited because, fresh grad, no one wants to take you, and then I worked there, and then I wanted more machine learning. And then I was doing even more Kaggle, and I improved my rating. I many competitions. I was in Kaggle Master at the time, and then it helped me to change a job and get something with traditional machine learning from morning till evening, and that's what I was doing for more than a year. I was doing traditional machine learning, but it was boring after some point. And deep learning, artificial intelligence, let's do it, it's pretty cool. And also at the time, about a year ago, there was a lot of competitions, at Kaggle, we got a lot of computer vision, deep learning, things like this. And I started investing a lot of time into this. I became Kaggle Master. I got some money last year, and I had a talk in H2O at some point about this. Here, there, and then, after some success, more gold medals and good finishes in Kaggle came into play, I was able to find, and again, Kaggle was a good factor in this in terms of knowledge and also as a line in my resume. I found a data science position in Lyft, and right now I work there, and my job, from morning till evening, deep learning, computer vision, and tight interaction with the mapping team and self-driving team and this type of the folks. So I want to say that Kaggle was one of the good factors, but not the only one that helped me to get interesting job, things like this. Yeah?
Hello, everyone. I'm Gilberto. I'm from Brazil. I'm graduated in electronics engineering in Brazil. I've been living here in the US for 1 year right now. And I work for AirBnB as a data scientist. I worked for the search ranking team and paid growth team at AirBnB, doing basically machine learning. Before being a data scientist, I worked for many years in Brazil as an electronics engineer, developing electronic hardware. Also, I work as an automation engineer in Brazil in Petrobras. And I met Kaggle in 2012 after a Google Artificial Intelligence Challenge. And I was very lucky in my first 2 competitions because I placed very well and got my Kaggle Masters title in the very first 2 competitions. And yeah, before doing Kaggle, I loved to play video game.
Sweet. Awesome. I'll grab this from you. Cool. So great introductions, and I'm so excited for our chat tonight. So my first question for you guys is, what originally inspired you to kind of get into Kaggle? What was the motivation? And like, how has that changed over the years? Branden, do you want to kind of take the first one?
Yeah, how I originally found Kaggle was I was at my last job, and my boss introduced me to our chief actuarial officer, and I mentioned that I was doing some statistics stuff, and he's like, "Oh, so you're into data science?" And I had never even heard of that term before in my life. So one of the first things I did was I Googled data science, about 5 years ago, and one of the first things that came up was Kaggle competitions. So I was like, "Oh, this looks interesting." So I'll go check out one of the competitions, and I downloaded the data set, and I was like, okay, I'm going to do this. And then I had no idea what to do. I barely knew R at the time, didn't know much about machine learning, although I was doing some linear regression stuff like in Excel and stuff like that. So then after that, I went on a binge for like maybe a year and a half of doing just online courses through Coursera, EDX, Udacity, I think was another one. Just trying to learn as much as I could about data science and machine learning, stuff like that. So I think I joined Kaggle 5 years ago, and it wasn't until maybe 2.5 years ago I made my first submission, probably. So yeah, what got me into it was just, I wanted to learn more about data science, machine learning, how to predict things, and because I wanted to apply this to my job, predicting if people would cancel at my old job or what pricing should be for options and stuff like that.
Okay, so as I mentioned, first time I learned about Kaggle, and it was like in this online class. About like 2 weeks after I learned that like word data science exists. Again, so in this sense it's similar to Branden. So my initial motivation was just like to have like more practice, especially because you see like data science is pretty easy. Machine learning technically it's just like some kind of high school, like maybe like freshman level like math, but it's enormous amount of like some small details. And it's all stochastic and structured, and it takes a lot of practice to master it and also to memorize it. And especially because you see, I was taking some class, I was reading papers, and I read this and I instantly forget. I wanted some practice, something like just to check my hands-on experience. And so yeah, I joined Kaggle. I barely knew machine learning because I just read some took some online class. And then, of course, I almost got PhD in physics. I have some papers, I feel great, I feel that I'm smart, I do submission, bottom 5%. Then I work really, really hard. It was 2 weeks before the end. I invested a lot of time, and basically I finished in bottom 10%. And it was basically this fixed gap between my expectations about my skill set and reality. And in this sense, again, I also recommended all my friends to do similar exercise, and it kind of works. So first I worked on the Kaggle competitions to get a lot of experience in a bunch of different problems and to memorize approaches and learn from other competitors, especially because people share their code, share their ideas, what worked, what doesn't, and that's what I did. Another thing that I like about Kaggle, so in the first probably my 9 months, I tried to participate in all competitions. And as you know, there are many competitions that are happening in parallel, and you just like spend 1 week on this competition, then 2 weeks another. You don't invest too much time to get like to the top, but still, as you like know, like 80% of the knowledge you get in 20% of the time. So, and I was like trying NLP. I have no idea what is NLP. Let's learn it. And then like in these 2 weeks of this extensive like studying, and I was writing my like thesis in parallel, you learn a lot. So you may be not an expert, but at least next time you have some kind of NLP problem, you know how to start, how to write your first pipeline. Then time series, then some sales, credit scoring. There was some computer vision, things like this. You jump from one to another and you learn a bit here, 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 and here. And this was happening probably for the first year. But then like, and all these problems, they looked really different. But at some point you start seeing, okay, this problem looks similar to this like 3 that I tried before. And this is also similar, and I started doing some kind of prioritization because all problems take too much time, and I had full-time job, and you also needed work to learn things that you don't really have in academia, like product feeling, interaction as a part of the team, and all these things. They were taking a lot of energy during my daytime job. So I tried like to work on some competitions that I didn't know how to solve. Basically, let's say I feel many people, they try to work and develop their skill in some narrow subset. Let's say they work like only like computer vision. Some other people only like XGBoost type problems. I tried to solve everything. Like, I don't know, let's do it. And this was probably like for the first year. Second year, I became comfortable with this like standard traditional machine learning techniques from different perspectives. And I focused, as I've said, more into like deep learning computer vision domain. And then again, it helped me to develop my skill, and then like I became better. And at some point around like middle of last year, maybe like it actually was like a year ago, I finished third with my teammate Sergey Mushinsky in this like DSTL competition, and we surprisingly got money. We finished third and we split it 20,000. And at this point, before this, I thought that like money is like for guys like Gilberto and like I will never be there, meaning like too much work and it's like lottery, so there's no money in Kaggle, only knowledge. But you know, when you get this 10,000 in your pocket, like perspective changes a bit. And after this, yeah, sure, like still knowledge is a big part of me, but like money and like the fact that it's like kind of can be reached became feasible and more attractive. And after this, like I finished like first in like recently in this Galvanize challenge, we got first place and split 12,000. There were a few competitions in summer, like outside of the Kaggle that also gave me some money. There was some interesting competition last spring in which everyone could participate, but only citizens from some subset of the countries can get like prize money. I finished second, was like nice, interesting story. I was shown all over Russian news for a couple days, but it's like separate discussion. Didn't get money, but like got some attention from Russian like mass media and like something like this. So yeah, basically, and what I'm trying to say that these days, like when I look at the Kaggle problems, most of them look familiar. In this sense, yeah, sure, like I don't want to say it because knowledge is the most important, but money slowly is becoming a factor, yeah? Another thing that I kind of like, also my attention kind of switched recently, and I realized again about like 6 months ago that every Kaggle competition, it's something new. It's basically guys that like can do state-of-the-art fight with each other. And it means what? You can publish this as a blog post, maybe as a paper, present it somewhere, and this is another way to basically spread like your knowledge and maybe also get some attention from companies, some like visibility. Because like what you have typically in Kaggle competitions, there's a lot of knowledge there, people like develop, struggle, like, you know, compete, they understand competition ends, they share their knowledge, everything is great, and that's it. Everything just got forgotten there in these forums and doesn't go to the like wide audience. And I tried like starting from this like last year to share my code with the audience, maybe write some papers, blog posts, and this kind of, I hope this helps because I mean, for this like code that I shared from the Galvanize challenge from, you know, from this like from fall, I got now like 200 stars or maybe more, and people share work and they use this in their research, maybe work, and this kind of also one of the priorities that I have right now, to find interesting competitions, to get good solution, to write some blog post, paper, to share, and yeah, that kind of it looks right now. Gilberto?
Okay, thanks. Well, what motivated me to join doing Kaggle at first was curiosity. I came from a different area, engineering. My previous work is completely different than the work I do right now. So machine learning and artificial intelligence is something that drives to curiosity to everyone. So I joined the two my two first Kaggle competitions just to learn. I want to know what's going to happen if I try to solve one machine learning problem. I had some very basic skills when I joined Kaggle, like programming skills, and I improved it a lot on the first year and the following years. But the first two competitions finished on the same day, and I placed 3 in one and maybe 11 on the second one. But it placed me as a master in Kaggle, and it's very interesting because I use only MATLAB and neural networks to get that ranking on the two competitions. That was the only tool I know, but at that time, because I used a lot of MATLAB to do engineering. And after that, I learned that exists another language like Python and R, and start to learn coding in Python and R. And I learned also that there are other kinds of algorithms to train a data set and to learn, and many other algorithms, right? So I start to learn decision trees, even a linear regression, a gradient boosting, and all those cool stuff that have to do machine learning. And my first year in Kaggle was just to learn. I learned a lot, actually, in Kaggle, especially reading the past solutions and merging things with another more experienced members. And after 2 years competing in Kaggle, I got something like top 30 or top 40. And I realized that I can try to improve even better my ranking. So after 2 years doing Kaggle, I started to compete really hard, like working more than 20 hours per week, just doing Kaggle in my spare time, like using my weekends and everything else. So after the second year, it becomes more something else. It's not just to learn, but I wanted that top positions. My goal for the next years is achieve at least top 10, and I made it. And about, I don't remember exactly the date, but about 2 years ago, I got the top 1 position on Kaggle. And after that, I'm relaxed. And now I do Kaggle just for fun and still learning a lot, because every day we can see many new algorithms coming, and we can learn a lot, still learn a lot, especially deep learning is a very interesting area rising right now. And yeah, now it's just to learn it for fun.
So I'm curious, without giving away kind of the secret sauce, what do you usually use? What does your workflow look like? What kind of tools are you using? How do you kind of start and end? Branden, do you want to take this one to start us off?
Yeah, so I started out mostly using R for most competitions, and then as I've gotten more into computer vision competitions, I mostly use Python now. To start a competition, probably one of the most important things when you first start is to actually read the description of the competition, which a lot of people don't do. They give you a lot of clues about what the data set's like and kind of problems you might run into on the test set. And then generally after that, try to do one of two things, usually or both at the same time. Just get a base model off the ground. Try to figure out what just your basic thing will score on the leaderboard. That way you can kind of measure your improvements, or if certain things you've tried with feature engineering help or different modeling techniques help with your score. And then the other thing is to figure out your validation strategy. It's probably one of the most important things, especially in 2-stage competitions where stage 2 data is not anything like the first stage data, or there's going to be something fundamentally different about it. So you have to figure out early on the right way to do your validation. And then after that, once you kind of got that going, kind of your base score, kind of move into feature engineering, data augmentation, various other stuff I've learned over the years to try. And then Usually with about 2 or 3 weeks left in the competition, if the competition warrants it, what I'm to do, start doing ensembling stuff, putting together multiple models, trying to figure out what works, if just a simple blend will work, or if I should, build another GBM or deep learning model on top of predictions from my other models and stuff like that. I think that's probably my general workflow.
Okay, so for me, workflow looks a bit different for traditional machine learning and for, let's say, deep learning, computer vision type tasks. Because I mean, some specifics here and there. In one, it's more about feature engineering, and second, like same amount of time, like network engineering if you want. So, and because again, like these days at work, I mostly do deep learning, and because like last year competitions that I was involved mostly were in the like computer vision domain, let me talk about this. So let's say I'm entering competition, cool. What's next step? So again, as Branden mentioned, it's extremely important to read like what the problem is asking, evaluation metric to understand maybe to what similar problem in the past have you seen, or maybe some approach that you've seen somewhere. Reason for this is, let's say if you're doing some kind of traditional machine learning and you work with tabular data, to get baseline, you can basically just like take this data, do label encoding, feed predict on XGBoost, and you get some kind of like value. Maybe it's like some overfitting, maybe underfitting, but you still some kind of like model that goes you like from like start from the maps data into submission, like score at the leaderboard. Computer vision and deep learning is a bit trickier in a way that because you have some data and you need, and typically this data has some like gigabytes, or maybe there was another competition recently, like more than a terabyte of data. And so to work with this, you need to write. So first thing that's important, like that you need to do, in like at least from my perspective in Kaggle competition, to appear at the leaderboard. Basically, in my again personal subjective opinion, every work on the competition can be like there's like binary split. You either excited about like problem, you read the description, you like played with the data, and it's kind of like kindergarten stage. And there's like adult stage. You made a submission. Maybe you're at the bottom of leaderboard. Maybe something like it's just not working well, but you are at the leaderboard. The reason for this is because it's extremely important to have some kind of baseline pipeline, again, that maps like your data into the score. Because after this, it's just like 10,000 iterations, trying ideas, reading papers, stealing ideas from the forum, talking to your friends, things like this. Iterations, iterations, iterations. Because it's like it was mentioned at NIPS in one of the most popular like talks that was like in December, deep learning these days, it's not really a science. It's not even an art. It's just an alchemy. So it's just like try, fail. There's some intuition behind many tricks, but still try, try, try. And to do this, you need like to iterate. You train model, something is training, at the same time you're reading paper about some new idea that you read somewhere recently. And again, in deep learning, there's a lot of progress these days, and there's a lot of new strong papers. Okay, 90% of them are garbage, but like 10% of them are extremely strong, and you need to implement them, you need to understand, you need like to find solution. And for many papers that you see in the internet about deep learning, there is no code, and you need to figure out based on like things that authors like skipped, like how to create this. So again, main idea for computer vision competitions, you either write your own pipeline or like copy paste it from the forum, it's totally fine. Even if you like don't know how to start the problem, like the best approach, you go to the forum, take a pipeline that someone shared and try to run it, appear at the leaderboard. Later on, you look at the code, you refactor it, you change it, update, modify, iterate, read more papers, classes, conversations. So basically 10,000 iterations because like deep learning is an alchemy. Yeah.
Okay, my approach for Kaggle competition is very similar to my friends here. Usually I start reading all the description of the competitions in details to understand what we're trying to solve. Because the most important question is what we're trying to solve, right? And then I download the data sets and start to analyze the data. Features, I start to get used with the data. It's very good to get used with the data, to take a look at the features you have, how you can play with the data. It starts to give you ideas on how to build new features, do some feature engineering, just looking at the data. And at the same time, you need to know what kind of data set you are working. So it helps you a lot to understand exactly the problem. The second step will be to build, try to find the best way to validate your model offline. This is the key feature to all the competitions, how you validate your model. Because you need some kind of offline evaluation of the performance of your model. Because in Kaggle, you have only the possibility to submit your test set predictions, right? But if you just submit your test set predictions, you have only the leaderboard feedback. But what about the local feedback of how good is your model? That's why we built that offline evaluation. So, and I spent some days or maybe weeks, like 1-2 weeks, just trying to find the best way to validate my model. When I got some offline performance similar to the leaderboard performance, I'm good with my cross-validation strategy, and I can keep going in the next step. Of course, it depends a lot of the problem. For time series, there is a different way to validate. For tabular, structured data, any data set is different. So you need to, this is very important to understand how to solve your problem and how to validate it offline. So once you have it ready, you know the data set, you know how to validate, and your validation is good, you start to train your models, try to improve your models. And a very good signal is if you improve your model in your offline evaluation strategy and it improves the same amount in the leaderboard, Kaggle's leaderboard, it's very good signal that what you're doing is right, is good, right? And I keep building models, as many models as possible, because one of the techniques to improve the performance of the models is do an ensembling or a blend of many different models. So I keep building as many models as possible, and looking for to do that ensemble on the end. This is my basic pipeline, my basic approach to Kaggle. But there are many details in all those steps. It's impossible to tell all the details here in the time, but this is the basic.
So yeah, I mean, all my colleagues basically already shared the standard approach to Kaggle competition. So I would actually add a couple of points. So first of all, one of the most important points actually is to establish a right validation schema. And the good thing about this skill of building a validation schema, of designing a validation schema, that because you can use this experience in real life, right? Basically, for any given machine learning task and data science task, you still have to design the right validation because you have to be sure your model actually works correctly. And I think the second point, I think you maybe Vladimir mentioned that already. It's I think that he is inventor of this term, basically a human grid search. So basically, a lot of people actually trying to different ideas, and they share these ideas on forums. That's usually very extremely helpful. So that might be a very good idea to have a look into previous competitions, trying to find the similar competitions was being held before. Because in that previous competition, you can find at least, a standard pre-processing steps, what should be done with the data, et cetera, et cetera. Or you might be actually, I think there was one story from one of the competitions, and the guy, he just applied his pipeline and a model from a previous competition, and he was immediately first, just because, competition was so alike. This was a same sonar data, basically, and he just applied his previous pipeline with the neural nets, and boom, he's on the first place. And I think he actually won this competition. So yeah, and the third point, it's mostly how I analyze the data set. So basically, I try to build the model first without basically analyzing and looking deeply into the data. Why I do so? Because the model feedback will give me additional insights about the data. Let's say if you build a random forest, actually can provide you a feature importance, or even a feature interactions, which features are a pair of features used the most. Same goes with linear model. If you build a linear model fit to your data, you can actually, by analyzing coefficients, you can already get some insights about what features might be the most useful, where to pay attention, which features actually you can ignore completely, et cetera, et cetera.
Okay, so before we go to your Q&A, and I hope you guys are submitting lots of great questions on Slido, I'm going to ask these guys just one final question. And so a lot of you have been on Kaggle for many years. And so thinking back, to when you first started, what is one thing you wish you knew then? What's one piece of advice that you'd give folks who are wanting to get better at Kaggle?
Okay, so if I look back at 3 years, what advice will I give myself? I would probably say sell your computer and buy Bitcoins. I mean, so actually Dmitry proposed this idea, but yeah, sure. Sounds funny, but there's some piece of truth there. Okay, so I would say maybe rephrase the question. Kaggle gave me so much in terms of analyzing the data, iterating fast, better tools, better code, ability to search for information. So all these things that I would like to know them when I joined graduate school. Because if I started doing Kaggle the same as other guys, not 3 years ago, but let's say 5 or 6, I would probably publish significantly more papers. And yeah, so I believe I started Kaggle in the right way. I tried to work hard. I mean, did my best. So I don't see any improvements in this sense. But again, if I knew about Kaggle 6 years ago, maybe the story would be different, and maybe I would sell my computer and bought Bitcoins, but still, yeah. Okay.
My advice, well, I must disagree with Vladimir here. I think the first advice is not find a physics graduation, it's find an electronics engineering graduation. Yeah, this is the first advice. Okay, seriously. Okay, if I can get back to the beginning, the first thing I can think about is getting a good computer, because it's unfair if you don't have a good computer competing with other people that have unlimited reserves of CPUs, GPUs, and so on. So you need to have a good computer right now. Maybe 5 years ago is not the case, but right now is it the case. I can say that a lot of people with unlimited hardware. So find a good computer. Try to do some online course and to understand what machine learning is and what are the algorithms available right now to solve the most different problems. What more? Yes. One very important thing in Kaggle is reading the forums, especially the past solutions from the competitions. It's very important to try to understand how the top teams solved the previous competitions. And especially if you can try to reproduce the solution by yourself, it will be good. A very good way to learn. Really, really good. Actually, most of my learns come from the forums, Kaggle forums. And this is a good. Okay, the last one, I would say, once you start Kaggle and you start submitting and submitting good models, maybe a very good trick is to ask a Kaggle master or grandmaster to merge things with you. If you can have a positive feedback, you can merge things with Kaggle master, grandmaster. It's a very good source of knowledge and a free consulting. Yeah.
So yeah, I think of course we can turn back time basically and go 5 years ago and give advice But as of today, I think I'm agree with Gilberto. Basically, you need a powerful machine, but you don't have to buy it. Basically, you can use AWS spot instances. They are quite cheap. Last time I used it was a year ago, I think. It cost me $50 per month during the competition, and it was basically enough. Well, of course, if you into deep learning type of competitions, that's a slightly different story. I'd suggest to have at least some machine with a single GPU, just to able to run some, a proof of concepts of your code, so you can buy AWS machine and run it on a full scale. So yeah, but you don't have to buy the machine right now because it's kind of scary, like putting like 1K or 1.5K into something like a piece of hardware without like knowing is it good enough. It's kind of hard. So yeah, but as for the rest, well, yeah, teaming up, it's a very interesting idea, but it really depends on a various of factors. So especially, on the time zone. If you, let's say, like on a West Coast and a person you're teaming up somewhere in Russia, for example, right, or in India, that's kind of hard to share advices. But you can actually do the same job, like 24/7. So it really depends.
I kind of have an answer now. I guess two things I would have told myself 3 years ago would be A, learn Python, because I've used R for about 4 or 5 years before biting the bullet and using Python a lot more. I still use R a lot, but I use Python probably 50% of the time now. And I wish I would have done that way sooner. And it kind of in conjunction with that, the reason I learned Python was because I wanted to do deep learning, and a lot of that's in Python using Keras or TensorFlow and stuff like that. And the reason I would have told myself that is because I think probably all the competitions right now are computer vision competitions. There haven't been too many tabular ones recently. So there's really been kind of a shift in that direction. And I feel kind of behind in that area. So if I would have known sooner, I would have felt a lot better right now.
Cool. So Vladimir, I think this one is for you. So what's your hardware setup like when you're doing deep learning competitions? What is your electricity bill?
Okay, this is a good question. Okay, so my hardware, as like Gilberto mentioned, good hardware is important. Basically, if you have like if you have, let's say, one GPU, maybe don't have GPUs at all, you still can win competitions. But you see, as I mentioned, there is like, it's machine learning, deep learning, it's all alchemy, and you need just like to do a lot of iterations. And so the key part to like just to win, it's of course like look at previous solutions, forum, etc. But realistically, you need to iterate extremely fast. Like a lot of you need to check ideas, because I mean, most of your brilliant ideas will not work. Some of your stupid ideas may definitely give you a lot. And like to figure out which works, what doesn't, you need like to iterate fast. And this leads you to hardware. Of course, you can do something in the cloud, but these days, I mean, as like Branden mentioned, most of them are computer vision. And data sets are relatively big, and you need to iterate fast. And you want your models to be like, have high capacity, meaning like they may require a lot of GPU RAM, basically even to run and things like this. So my setup, at home I have 2 computers. In one of them I have 2 Titan Pascal X, each of 12 GB of RAM, and this I use for prototyping, for developing, basically developing like proof of concept, this type of the task, yes? And again, I would prefer 2 GPUs rather than 1, because again, these days, and in general, most, like 99% of the network architectures can be like parallelized well between multiple GPUs, and I would prefer out of the box to write like code that can run on multiple GPUs. And that's why I have 2 GPUs in my main computer, just for prototyping. And I also have another computer that I bought like from the prize money in somewhere like, I believe in June. It has 4 GPUs for 1080 Ti. So when and it doesn't have like monitor connected to it, and so when like I'm developing some model, I prototype and then I send it to this like dev box that I have in my like room, and it's like working, like training something there. About electricity bill, I believe I'm paying per month $250 like dollars per month, yeah, for electricity. But because these days cryptocurrencies and all these other beautiful words, in the breaks between like deep learning, so let's say right now at home on one computer I'm like training some network, and in second one like I'm not training network, what I'm doing, I'm like crypto mining. And this gives you, if I will not do deep learning these days, it will give me this like 6 GPUs, will give me from $1,000 to $2,000 per month. So in this sense, like this, like being scared about like bill is not really a thing, because I mean you can compensate this with other activities that you can use for your GPUs. Yeah.
Nice. So, Gilberto, question for you. What was your most challenging Kaggle contest and why?
Let me think about that. Most challenging, maybe the first 2. I had no experience on the first 2 doing competitions, doing machine learning. It was about energy forecasting using wind as a feature. if I remember correctly. I had to think out from myself. How to do the validation. I had no theory at that time. I know no theory about machine learning at that time. So I find my own way to build my models, to validate offline, to do hyperparameter tuning and search for a network architecture. And I was able to place very well on those two competitions. Yeah, the first two ones.
Awesome. Dmitry, question for you. Do your Kaggle credentials at all help when folks are looking for a job? On the other side, when you're interviewing candidates, do you look at their Kaggle background?
Well, let's start from the end, basically.
Sure.
Of course, I'm extremely biased, right? So because I'm a Kaggle Grandmaster, and as somebody I look in someone resume, obviously I will pay attention to their Kaggle rank. If they provide some like their Kaggle profile, I will definitely pay attention to that. For a first type of a question, actually that's a very valid question, because that's exactly how I get into the data science industry. Because I was a data warehouse engineer and architect. But I learned about Kaggle. I basically got addicted myself to Kaggle. I spent I think 2 years on Kaggle. I was a master at the moment, and I almost decided you know what? It's kind of expensive hobby. Why don't I actually get myself paid to do what I like? And I decided to switch to data science career. And for me, it was extremely helpful, to mention I have some good results on Kaggle. So, but at the moment, I was in top 100 at least, as far as I remember. I already won 2 competitions. So it was my point is, let's say if you don't have a decent results, it actually might hurt your resume instead of helping it. You're supposed to have a very solid Kaggle profile if you really want to provide it in a resume. Let's say if you provide hey, I have a Kaggle profile, I finished 2 competitions in top 1,000. That's kind of okay, sure, good for you. Next. So because I know how. I would say for a lot of competitions, it's very easy to win a bronze medal right now. So it's been, do you remember what kind of percentage it is? Like a top 10% or something, the bronze medal? But by just combining available kernels and available solutions, you can win bronze. Sometimes you can even win silver, actually. So that means if you just provide hey, I was 1,000th or out of 2,000s, that means nothing basically. Because you can, by carefully looking what people actually posted on forum, you can do better than that.
Awesome. So Branden, this question is for you. Have you grabbed the mic real quick there? So Branden mentioned feature engineering. Are there any general techniques you use when doing that?
Yeah, so one of the ones I probably use most is target encoding, which is basically when you have a categorical and there's a lot of different classes in it, rather than one-hot encoding it, which expands your data set. Basically, it's more complicated than I'm going to make it sound right now. Is basically you take the average of the target and then encode that as the categorical. So if every time class A comes up, if the answer's 100, then you'd encode A as 100. But you got to be careful when doing that. Like I said, it's a little more complicated because you're going to make your model overfit. So you want to do that, leave one out, and do some cross-validation stuff. What's the paper on that called? I think there's a paper on it called the high cardinality target encoding. So you can find that. That's one of the main ones I do. Feature engineering, other feature engineering stuff. Another one, if you have categoricals, you can. If you have categoricals and numerics, then if you have a categorical, you can average together the numerics for that categorical. Similar to target encoding, but you're doing it just another predictor column, doing that together. There's a whole bunch of stuff. There's actually, I think I have a talk online where I expand on different feature engineering stuff I did at one of our H2O Worlds last year. So you can find that on the H2O YouTube probably. But yeah, I talk about target encoding, feature engineering stuff a lot.
Awesome. So, Vladimir, you mentioned that your team won a competition, and one of the questions is, how did you find teammates for Kaggle competitions?
Okay, so typically, how do teams form at Kaggle? So they're like, sometimes people heard about Kaggle, they never tried, they like got excited about some task, like maybe deep learning, maybe like a lot of money, maybe something else, maybe they want to get this line to their resume, and they're extremely excited. They join together, talk about this, let's do a team, let's win this competition, let's work hard. Typically, they don't even do submission, they are very excited, and then it dies off. And basically, it's not the way to form a team. Better, and what is typically happening, at the Kaggle, let's say you're working on some problem, you're working hard, let's say you go to some place, I don't know, 10, 5, 50, 100,000, doesn't matter, and you're stuck, and you're out of ideas, and basically you're trying, nothing works anymore, you're basically no ideas more. You read forum, you ask friends, still you're stuck, there is nothing else to do. I mean, typically, again, let's say I'm 10th, yeah? And then this last competition was something similar to this, I was 5th, yeah? And then I don't know how to go higher because 5th and I want to get first or maybe something. And then there's some other guys that they are 2nd, yeah? And they're also out of ideas and they tried everything they hard and they're 2nd, they want to be first, but it doesn't work. And at this moment, what happens probably about 2 weeks before the end, I mean, people look around at the leaderboard and they ask someone who's nearby. Basically, it's unlikely that you are 5th or 10th, and you ask guys on the 10th place, do you want to join me? No, it doesn't really happen. So people try to find someone who has similar standing. And why do they do it? Because as Gilberto mentioned, ensembles can give you something. Not too much, but in world of the Kaggle competitions, when people fight for the 5th digit after the decimal point, you need just a bit. And often it's just enough to take 2 strong solutions from 2 different people that had the ideas. Solutions have similar score, but they're different. And let's say you take average or blend or do some kind of ensembling, and this allows you to go higher. So at least how it was for me, and I believe how it's one of the ways to form a teams, you look for someone, the leaderboard, who is near you, and at the moment where you still have some time for teamwork, but you're stuck, you don't have any ideas, you just propose to guys near you at the leaderboard to merge and to form a team and try to go higher.
Awesome. Gilberto, question for you. What online courses would you recommend for folks?
That's a hard question for me. I made some online courses very early when I start to learn, but there are a lot. The most common courses comes from Coursera, Udemy, and I think this is. Yeah, sure.
So basically, I have something to add. Basically, right now on Coursera there is a course available which called, I think, Competitive Data Science, and basically that's course exactly what to do to win Kaggle competition. So, yeah, and actually this course actually was designed by Marius, who is right now a 3rd, and a couple of other Russian grandmasters. So it's not just some people who just have a theoretical knowledge. That's the people who actually won competitions and they know how to do it and they share their advices. I say, common techniques, what to do and how to win, basically.
Dmitry, question for you. How do you manage large data sets?
Pray to God, basically. It depends, basically honestly on Kaggle there is not that big of data sets. So let's say for deep learning competition, because all you need to do is just have a batch, right? So you don't have to consume all the data available. It's a batch learning. For classical machine learning competitions, usually 32 gigabytes of RAM or even 64 is usually enough completely. So, and nowadays you actually can rent 2 terabytes of RAM machine on AWS, and actually we did it before for a competition. So that's definitely enough for any possible Kaggle competition for sure.
Cool. So this one is for Vladimir. Vladimir, curious how to prepare for NLP jobs.
This is a good question. I have no idea. because as I mentioned, you see, like my first job was more like in the domain of heuristics. Second was traditional machine learning, like click-through rate type problems, recommender systems. And right now it's mostly computer vision. So I mean, I have some like NLP background based from like that came from Kaggle competitions that to some extent I performed well. But I have limited experience in terms of like how it should be deployed and what questions, what nuances do you have. And again, I want to emphasize that Kaggle competitions and stuff that you do at work have big overlap, but like they're still like relatively different. But I believe Dmitry can answer more detail for this, yeah?
A couple points to add, basically. So for NLP, I think it's still a huge area of research. So we don't have a significant improvements, let's say, applying deep learning to textual problems. You know, let's say for text, I'm somewhat familiar with the text classification and sensitivity analysis, and the difference between deep learning models and like a classical linear models approach is not that significant. It's not like extremely practically significant. You know, because for images, the gap between a classical approach and deep learning it's very huge. For NLP tasks, it's you know, like it's still ongoing, I would say, especially for business-oriented problem. So there is some significant improvements in sequence-to-sequence, for example, architecture, when you can translate text from one language to another. And basically, that's it, I think, from my knowledge. So, yeah.
Gilberto, this one is for you. Are the skills you learned from Kaggle useful at work at AirBnB?
Very good question. Yes, it's useful, but it's different. At Kaggle, we have a fixed data set, right? Data set don't change every day. So you can extract the best performance of that data set on Kaggle. On Airbnb, I have a huge data set arriving every day. So I can use some knowledge learned from Kaggle, but I need to apply the different way. I still can use some ensembling in Airbnb, but as I told, it needs to be a simple ensembling. It's not going to be like a huge ensembling with 100 different models. But one thing that's is valid for enterprise is the validation strategy. The validation strategy I learned from Kaggle, I can apply directly in Airbnb to validate all my models offline, right? It's very important. I see a lot of people doing the validation not correctly, and this is a good learning from Kaggle. Yeah, that's basically it.
Awesome. So Branden, this one is for you. What would you say is the biggest difference between Kaggle analysis and competing on Kaggle and the actual data science work in a business organization?
I don't know, because a lot of my problems I work on in business are, you know, we specifically design them almost to be kind of Kaggle-esque. So, you know, we get like a business problem and we turn it into basically kind of a Kaggle competition in a way, just kind of like a little internal one. Let's see who can engineer the best features and you know, create the best model, figure out what models work, what models don't, or which algorithms work, which algorithms don't. So, you know, for me personally, a lot of the time there hasn't been too much of a difference, I guess. I guess one of the main differences is that we actually have people that actually go and inspect some of the errors that we're making. So in a Kaggle competition, you have like a single score that you're aiming for. And if that score is good, then you're good. Whereas in business, sometimes we have a score that's good, but then we have people that go inspect, you know, certain predictions and they're like, why did you get this one wrong? Like, it's very obvious to me why this should have been this number. So then you kind of have to go back and be like, okay, you know, let's fix this model, see if we can find, you know, some features that I can make to, you know, help make that prediction better, you know, a group of predictions better. Whereas in Kaggle, you don't necessarily have stuff like that.
Awesome. Vladimir, a question for you. Are there any reliable resources to learn how to properly build validation sets? It seems more like an art than a science.
I mean, so this is definitely true. So problem with validation, if you read some textbook, they tell you like you take your data, split into 5 folds, random shuffle, life is great. Yeah, sure. I mean, so first of all, like one thing that is a bit different for computer vision competitions and which I really like. So as Gilberto mentioned, you need to have like, local validation score, improvement here and there, numerics. In computer vision, you can look at your predictions with your eyes. I mean, you maybe don't know what is like prediction score here and there, but if you can see some artifacts on the boundaries, maybe some boundary effects, you can find like areas that your network is focusing on when it does its prediction. There are like some few techniques for this. It definitely helps you. I mean, you try to find something and it tells you that it's like focusing on zebra in the background. I mean, probably try to cut all zebras or something, I don't know. So basically, in terms of validation, when you work with computer vision, like basically visual inspection is must-have. You like look a lot, you try to understand why, how, and like do like fix your predictions based on this. I forgot the question. What was it?
I think you gave some good
Okay.
resources.
So how to like how to basically like do good validation. Let's say you work with time series. Let's say you do it at work. Yeah. Why can't you just like split something in 5 folds, look and do business? Because I mean, from the business perspective, you're interested in creating models that in terms of time series will work on something in future. So it like enforces you to do some kind of tricky validation, yeah? Or maybe you like, again, in business perspective, you just like work on something and you train some models, maybe on images that were trained on San Francisco and you apply this in Boston. And distribution is different, maybe images are different, maybe something else, and it doesn't really work. So, of course, there are some online resources, blog posts, how to do validation properly. It all like is very cute, but doesn't really work that well. It may give you some ideas, but the best approach to learn how to do validation, you try some kind of Kaggle competition, you do best that you can, and then you do your validation, you do it locally works, you do prediction, doesn't work, doesn't match. Because you did everything properly. You read some blog posts that tell you, yeah, you're right, it doesn't work. You go to the forum and there are like 10,000 guys complaining that like this standard approach doesn't work for them. But some of them, some guys saying, but if you do this, this, and that, like, it worked for me, and you learn it, you will remember, because this pain about validation is not working is deep in your heart, and it's touching string of your soul. I mean, so yeah, and then you repeat this, and basically more problems that you work with, that we have problems with validation, and for some problems, for example, this competition that me and Sergei Mashinsky finished like third and split at 20,000 last year in spring, no one knows how to do validation, even now. Because I mean, you have like train set as one distribution, public leaderboard second distribution, private leaderboard third distribution of the data. How to do validation in these circumstances, who knows? What saved us? Visual inspection. We basically looked with our eyes, all numerical improvement here and there didn't work, and so basically that's how it worked. So my main advice, how to learn how to do validation properly, go to Kaggle competitions, try, fail, learn.
Very nice. Gilberto, question for you. What was the most interesting paper that you've read in the past year?
I didn't read any paper in the past year.
You've been too busy on Kaggle.
I read a lot of forums, machine learning forums, especially from Kaggle. Yeah, but I'm not completely. It's not completely true. Yeah. I took a look at some papers, especially from deep learning. All the papers that comes from deep learning are interesting. I've seen some NLP approach for deep learning and computer vision approach. Every day there's a new paper about those areas. So, yeah.
Awesome. So this is a question I'll ask all of you. What is the largest amount of competitions you've competed in at the same time? It's to you.
I think 4, probably 4. I don't do that anymore. I do mostly one at a time now, or 2 at most. But yeah, 4, and that was tough. It's tough to manage. You think you're working on one competition, typing up code, and you're like, oh crap, that was supposed to go to that other competition. So yeah.
So for me, as I mentioned, like in the beginning, I tried to participate in all competitions because I mean, you learn something from the beginning, at least how to approach the problem, and you get pipeline that will help you like in the future competitions of the similar types. So probably similar to Branden, 4 or 5 competitions, but it's not like really competing, it's more like participating. So it wasn't like the hope to get good result. It's more about try to do my best. Like Win, of course, like didn't work that well in the first like 6 months, but basically to learn, 4, 5 at a time. These days, no more than 2 probably. And especially in this sense, you see, for deep learning, it's a bit easier because some of my models, there was some competition like Cdiscount that was going like fall of this last year. Data set was 12 million images, and you need to like, train it like for classification for 5,000 classes. In comparison, this like famous ImageNet like data set that everyone is referring to is only 1.2 million, so like 10 times smaller, and you need 1,000 classes. So basically, this Kaggle competition was like like order of magnitude bigger than ImageNet and like more complex. And basically, like I had this sum on this. I wrote some code, some pipeline, basically classification, fit predict, nothing like rocket science type like. And yeah, I thrown this to my dev box, and it was training there for a couple of weeks. Good, and then this like on my 4 GPUs, like, and at the same time, because I mean it's training, I was working on some other competition, like more involved, thinking, iterating on smaller data set. But yeah, these days it's like rare exception. Typically, like 1 competition is good enough because, yeah.
Sorry, what's the question?
Okay, can you repeat? Interesting. I mean, so question is like, how many competitions did you participate at the same time, and what is this maximum number?
I used to join all the competitions in Kaggle, so for multiple times I competed in more than 1 competition. I think once I was participating in 4 competitions at the same time. It's not easy to split the time between all the competitions, and you need more than 1 computer to do all the training tasks. Usually, I don't work all the time in a competition, but my computer works like 24 hours a day. So I try to prepare some scripts to keep running for the weekend or for never stops. I always try to training a model, to improve a model, building new features, doing feature selection, and try to find some way to improve the model performance. So my computer never stops. But it's not easy, especially if you merge things in multiple competitions at the same time, because you need to contact all the team members for all the teams, and sometimes the problems are completely different. Sometimes you are mixing classification, regression, multi-class classification, deep learning. So it's not an easy task. I don't recommend. Usually 1 competition is enough, one at each time. So you can learn better if you do only 1 competition at a time.
Well, to me, the maximum number of competitions I was participating at once was 3. And it was a terrible, terrible idea. So I'm kind of with you, Branden. So let's say to make the competition process enjoyable, it should be 1, maximum 2 competition at a time. After that, it becomes not enjoyable at all.
Okay, so we're going to start wrapping up here shortly. There's a lot of remaining questions, but we'll do like 3 or 4 more. One question that I have for you guys, which I think is very interesting, is what does Kaggle tell you about the state of machine learning? Are there any challenges you expect to see but don't? Are there certain challenges that you feel are a little bit overrepresented?
Well, right now I think computer vision is overrepresented, but it's just because I'm not good at it and I'd want to do some tabular stuff. But yeah.
I believe you have right amount of computer vision competitions. So what I would like to see more, I would like to see more time series predictions, especially time series related to deep learning. Not like it's kind of hard and tricky, and maybe because, as I mentioned, for me it's also like place to learn, and like these days computer vision doesn't really scare me like any type of the application. Like sure, I'm pretty comfortable. I have pipelines from some previous tasks. Time series like speech, this type of like maybe text to text, something like this, I'm not really comfortable with. So that's why I would prefer like more of this type of the competitions. And another thing that I would like kind of interested in, I mean, sure, it's great that we have supervised machine learning here and there, and we're training, this is great, but like amount of data that is unlabeled is huge in the internet. So I personally would be more interested in like kind of excited about some unsupervised or maybe semi-supervised type like machine learning competitions.
Right now, Kaggle have a very good balance between types of competitions. It's not true 2 years ago. Right now, we have the same amount of image classification and NLP, structured data sets. So, yeah. And there's a new type of competition right now in Kaggle that is very interesting. They are called the kernel competitions, that you need to use Kaggle resources to build your solution. And there are some constraints, like CPU constraints, memory constraints. You need to build your code to run with that constraints. That's very interesting. Maybe Kaggle needs to build more competitions in this format.
Dmitry, question for you. How much, if any, visual exploration of the data sets do you do prior to designing your models? Does that depend on the competition? What packages do you use?
Like visual exploration, I wouldn't say like I use it too much, basically. Okay. The only thing I'm actually looking into that's maybe distribution plots, like histograms, maybe QQ plots, and basically residual plots, and that's basically it. And because I use Python, I just use some, I think, to be honest, the capabilities of pandas to plot different pictures, that's enough for me. Of course, before I was a Python guy, I usually use a ggplot too, for sure, because that's the best package ever for visual analysis.
Awesome. So I think we're going to wrap it up here. Thank you all very much for coming tonight, and thank you to the panelists.